The Atlantic Wall is remembered as a monument to German concrete, an immovable fortress stretching across Europe's coast. But some of the most important weapons used against it left no craters, no ruins, and almost no trace at all. While Rommel was focused on what could be seen above ground, Canadian engineers were quietly weaponizing what couldn't be seen, pushing narrow steel pipes through the soil, turning the earth itself into a minefield. These were the Canadian pipe mines, invisible weapons that haunted German planners, distorted their defenses, and undermined the Atlantic Wall long before the first Allied soldier reached the beach. Many of us grew up with the image of the Atlantic Wall as an impenetrable gray monolith. We were told of thousands of tons of reinforced concrete, of the Todt organization working night and day, and of Erwin Rommel's personal obsession with every pillbox and tank trap from Norway to the Spanish border. It was a masterpiece of static defense, designed to make any cross-channel invasion a literal suicide mission. But there's a nuance to history that often gets smoothed over in the textbooks. You see, the German High Command fell into a classic trap. They mistook thickness for invulnerability. They believed that if you built a wall high enough and thick enough, the laws of physics would simply side with the defender. But while the Wehrmacht was pouring concrete, a group of Canadian engineers, men who often understood the poetry of soil and steel better than the generals, were looking at that same wall and seeing something else entirely. They didn't see a wall, they saw a series of pressure points. This is where the fortress illusion begins to crumble. If you've ever worked with heavy machinery or handled a renovation on an old house, you know that the strongest-looking beam isn't always the safest. It's all about where the load sits. The Germans built for a frontal assault, expecting a horizontal force, ships firing from the sea, men charging up the sand. They weren't prepared for a vertical threat coming from beneath their very feet. This wasn't just a failure of construction, it was a failure of imagination. The invisible saboteur wasn't a spy in a trench coat. It was a series of humble steel pipes born out of a desperate 1940 requirement to defend British airfields against a German invasion that never came. General Andrew McNaughton, a man who believed that science is the best soldier, realized that if you could place an explosive precisely under a structure rather than against it, you didn't need a massive bomb, you just needed a lever. Think of it like this. If you try to punch a hole through a concrete wall with a sledgehammer, you're going to be there all day. But if you can slide a tiny wedge under the foundation and apply just enough pressure, the entire weight of the wall becomes its own undoing. It's the difference between brute force and architectural judo. The German engineers were brilliant, make no mistake. They utilized hedgehogs and quintet elements to snag landing craft, but they were looking outward. They were so focused on the horizon that they ignored the ground they stood on. History suggests that this is a recurring theme in warfare. The more a nation invests in unbreakable defenses, the more it blinds itself to the simplest workarounds. By 1944, these Canadian pipe mines, long, thin tubes filled with high explosives, could be driven horizontally under a road or a bunker at a rate of dozens of feet per hour. While the German sentries were watching for the flicker of a muzzle flash from the sea, the earth beneath them was being hollowed out. It was a psychological masterstroke as much as a physical one. Imagine the confidence of a soldier inside a 6-foot-thick bunker, only to realize the very ground is about to vanish. The story of the pipe mines isn't just about explosives. It's about the moment the world's most advanced military bureaucracy was outmaneuvered by a group of engineers who understood that the best way to break a fortress isn't to hit it harder, but to change the rules of the game entirely. To understand the sheer audacity of the McNaughton Gamble, we have to take ourselves back to the summer of 1940. If you're old enough to remember the stories your fathers or uncles told, or if you've spent time studying the grit of the greatest generation, you know that England wasn't the fortress it became later in the war. After the miracle at Dunkirk, the English army returned home with their lives, but they left their dignity and nearly all of their heavy equipment on the French sand. At that moment, the United Kingdom was a defenseless isle in every sense of the word. They were facing the most sophisticated war machine the world had ever seen, with little more than hunting rifles and a stiff upper lip. This is where the narrative of the gamble begins. It wasn't born out of a desire for innovation. It was born out of the cold, hard reality that they had run out of traditional options. General Andrew McNaughton, the commander of the Canadian First Army, was a man of science, a physicist by training, and a soldier by trade. He looked at the vast stretches of English coastline and the vulnerable airfields and realized that if the panzers landed, the British didn't have enough anti-tank guns to stop a single division. But where others saw a lack of steel, McNaughton saw an abundance of earth.
He proposed a radical idea. If you can't hit the tanks from the front, you hit them from below. But how do you plant mines under a runway or a primary road without digging it up and alerting every German spy in the county? This was the gamble. McNaughton decided to repurpose civilian technology, specifically oil well drilling equipment and horizontal boring techniques, to turn the very infrastructure of Britain into a dormant trap. Imagine the scene at a quiet RAF airfield in 1940. While the Spitfires are scrambling overhead, a group of Canadian engineers is working on the perimeter, seemingly doing maintenance. In reality, they are using a specialized hydraulic jack system to push 2-inch steel pipes hundreds of feet horizontally beneath the concrete runways. These weren't just pipes, they were McNaughton tubes. These tubes were designed to be filled with an explosive known as nitroglycerin desensitized soup, or amytal. By pushing these pipes 5 to 10 feet beneath the surface, the Canadians created a way to instantly crater a runway or a road the moment the Germans tried to use it. You have to appreciate the psychological weight of this. In 1940, the British were terrified of the fifth column, saboteurs from within. McNaughton flipped that fear on its head. He became the internal saboteur for the right side. If the Wehrmacht seized an airfield, they would find it perfectly intact. They would bring in their transport planes, their fuel, and their men. And then, with the turn of a single key in a hidden bunker miles away, the entire airfield would erupt from the center out. History suggests that we often overlook the passive side of heroism. We celebrate the charge, but we forget the man who spent 18 hours in the mud, calibrated a hydraulic jack to ensure a pipe didn't deviate by a single degree over a 300-foot push. If the pipe veered upward, it would crack the concrete and reveal the trap. If it veered downward, the explosion would be muffled by the earth and failed to destroy the target. It was a game of inches played in total darkness. For our demographic, we understand the value of doing it right the first time. McNaughton's men weren't just soldiers, they were precision craftsmen. They installed miles of these tubes across southern England. It was a massive, invisible grid of destruction. The desperate plan worked, not because it repelled an invasion, but because it provided the one thing the British High Command lacked: time. Knowing that they could deny the enemy the use of their own infrastructure gave Churchill the breathing room to rebuild the conventional army. But as the threat of invasion faded in 1942, these Canadian engineers didn't just pack up and go home. They realized that if this technology could be used to defend an island, it could also be used to tear a hole in a wall. The defensive gamble of 1940 was about to become the offensive secret of 1944.
The shift from defense to offense required a complete rethinking of the technology. In England, they had all the time in the world to jack these pipes into the ground. In Normandy, they would have minutes. They had to take a static, heavy system and make it mobile, lethal, and most importantly, deceptive. They weren't just building mines anymore. They were building a way to fool the Wehrmacht's finest engineers into thinking the ground was solid, right until the moment it turned into a graveyard of concrete and rebar. To truly appreciate why the Canadian pipe mines were such a breakthrough, we have to move past the what and look at the how. For those of us who have spent a lifetime working with our hands, whether in a machine shop, on a farm, or on a construction site, we know that the earth is not a friendly medium. It's heavy, it's unpredictable, and it fights back. The secret geometry of these pipe networks wasn't just about digging holes, it was about the physics of soil displacement and the purple value of the H2 force. In the early 1940s, if you wanted to get an explosive under a road, you typically had two options. You could dig a trench, which was slow and obvious, or you could try to tunnel, which was dangerous and even slower. But the Canadians perfected the horizontal forcing method. That was deceptively simple, but required a master's touch. It started with a jacking pit, a hole dug a few yards back from the target. Inside this pit sat a massive hydraulic jack. The purple secret here was the alignment. If you were off by even half a degree at the start, by the time that pipe traveled 100 feet, it would be 5 feet off target. To a 65 man who has ever tried to drill a straight hole through a thick piece of oak, you know that drift is the enemy. Now imagine that oak is compacted British clay and flint. The engineers developed a pilot head, a pointed tip on the lead pipe. As the jack pushed, the pipe didn't remove the soil, it compressed it. This created a packed sleeve around the pipe, which meant the ground above didn't settle. This was vital for the fortress illusion. If the road surface dipped or cracked, the German aerial reconnaissance would spot it instantly. By using the secret of soil displacement, the Canadians kept the surface looking pristine. The invisible saboteur was truly invisible. A single pipe mine is a nuisance. A network of them is a catastrophe. This is where the therefore logic of the Canadian engineers shines. They didn't just push one pipe and call it a day. They developed a geometric pattern known as the crater chain. If you place a series of 300-foot pipes parallel to one another, spaced exactly 15 to 20 feet apart, you aren't just creating individual holes, you're creating a shear plane. When these pipes are detonated simultaneously, the shock waves don't just go up, they meet in the middle. This creates what engineers call a V-trench effect. Instead of a few small potholes that a panzer could crawl over, the entire section of the earth, thousands of tons of it, is lifted and then dropped. The result isn't a hole, it's a canyon. To an invading force, this is the ultimate but in their plan. They have the tanks, they have the fuel, but the road they were counting on has literally ceased to exist.
Now, we have to talk about the but that the Canadians faced. Friction. If you've ever tried to push a long pipe into the ground, you know that the further it goes, the harder it gets to push. The soil grips the sides of the pipe with thousands of pounds of force. To solve this, the Canadians didn't just use more power, they used lubrication and vibration. They discovered that by rotating the pipe as it was pushed, a technique borrowed from oil derrick boring bars, they could reduce the friction by nearly 60%. This allowed them to reach lengths of up to 330 feet. For a man who values precision, this was the pinnacle of wartime engineering. They were essentially threading the needle of the British countryside. And they did it with such silence that a person standing on the road above wouldn't even feel the vibration. Once the geometry was set and the pipes were in place, the question became, what do you fill them with?
You couldn't just slide sticks of dynamite down a 300-foot pipe. They would get stuck, or the gaps between them would cause a misfire. The solution was a specialized explosive slurry, often referred to by the men as the soup. This was a mix of amytal or nitroglycerin that was liquid enough to be pumped or pushed into the tubes, but stable enough not to explode from the heat of the friction. History suggests that the real genius was the detonation cord. They ran a high-velocity fuse called primacord through the entire length of the pipe. This ensured that the 300 feet of explosive detonated in a fraction of a millisecond. If the explosion rippled from one end to the other, the force would be dissipated. By making it instantaneous, they achieved a heave that could flip a 45-ton Tiger tank like a coin. While the Canadians were mastering this geometry, the Wehrmacht was building the Atlantic Wall. The Germans were masters of concrete, but they were static in their thinking. Their engineers, the Pionier, were trained to look for mines in the surf zone or buried just beneath the sand. They weren't looking for deep-bore mines. Their detectors, the early probing needles and electromagnetic loops, could only see about 12 to 18 inches into the soil. The Canadian pipes were sitting 5 to 10 feet down. The German intelligence gap wasn't just a lack of information, it was a lack of technical imagination. They assumed that if their detectors were silent, the ground was safe. They were relying on a 19th century understanding of mining in a 20th century war of physics. Think about the men who did this work. They weren't the ones charging the beaches with fixed bayonets, at least not yet. They were the ones in the mud, calculating PSI, checking levels, and ensuring that the geometry of death was perfect. It's the kind of work many of us can relate to. The kind where if you do your job perfectly, no one notices you were there at all. The pipe mines were a triumph of the quiet professional. They turned the very earth of the British Isles and later the French coast into a sleeping giant. But as 1944 approached, a new problem emerged. It's one thing to plant mines in your own backyard in England. It's quite another to do it on a beach in Normandy, while the most feared army in the world is shooting at you from a concrete pillbox. The transition from the quiet push to the Normandy chaos would require one more leap in engineering and a healthy dose of deception. In the world of military intelligence, there's a concept known as reflexive control. It's the art of feeding your enemy exactly the right amount of truth so that they end up defeating themselves. As we move into the middle of our story, we encounter a fascinating but that changed the course of the war. The Allies had perfected the pipe mine, but they realized that a secret this good is often more valuable when it's whispered than when it's kept silent. To a man who has spent years in industry or management, you know that sometimes the threat of a problem causes more disruption than the problem itself. This is exactly what happened with the intelligence leak. By 1943, the British and Canadians knew that German spies were active in the UK. Instead of tightening every bolt of silence, the Allied High Command decided to use the McNaughton Tubes as a psychological weapon. They allowed fragments of information about underground horizontal tunneling to reach German intelligence. Why would you tell your enemy about your secret weapon? Because if the Germans thought the Allies could tunnel under any defense, they would stop looking at the horizon and start looking at their own feet. The facts from the intelligence archives show that the Wehrmacht became obsessed with the tunneling threat. They began to divert thousands of tons of concrete, precious material needed for the Atlantic Wall, into deep, reinforced anti-mining floors for their bunkers. They weren't just building walls anymore, they were building subterranean cages. This was the deception at work. Every hour a German engineer spent thickening a floor was an hour he wasn't spent building a gun emplacement.
History suggests that the Germans were particularly rattled by reports of liquid explosives. The Canadians had leaked the idea that they could pump the soup into any existing pipe, sewage lines, water mains, or even hollowed-out cable ducts. Imagine you are a German commander in a captured French town. You've moved into the local town hall. Suddenly, you receive a report that the Canadians have perfected a way to turn the very plumbing under your desk into a 500-pound bomb without ever breaking the surface of the street. This created a technical paranoia. German pionieri began to spend their days in the basements of French villas using stethoscopes to listen for the hum of Canadian boring machines. They were chasing ghosts. The purple value here is the resource drain. The Allies were winning the engineering battle before they even set foot in Normandy by forcing the Germans to defend against a ghost technology. There was, however, a massive risk. If the Germans captured a functional McNaughton tube, they could reverse engineer it. For a mature audience that understands the stakes of industrial espionage, this was the ultimate high-stakes game. The Canadians had to ensure that any pipes found in England looked like failed experiments. They intentionally left dud equipment in areas where they suspected German surveillance was watching. They made the process look clunky, loud, and ineffective. When the German High Command received reports on these pipe mines, the reports were conflicting. One department said they were a revolutionary threat. Another said they were a Canadian pipe dream that didn't work. This data fog is the hallmark of a master architect of war. It forced the Germans into a state of indecision. In military terms, indecision is a death sentence. If you've ever had to troubleshoot a machine while someone is looking over your shoulder, you know the pressure. Now imagine that someone is an entire intelligence apparatus. The Canadian engineers had to maintain their quiet professional status while effectively acting as stage magicians. They developed a sacrificial geometry. They would build a real pipe network, but surround it with fake wires and dummy sensors. If a German spy saw the dummy setup, he'd report back a completely false method of operation. It's like putting a fake alarm system sticker on your window. It's often more effective than the alarm itself. The result of this intelligence leak was a Wehrmacht that was looking for the wrong clues. By the time 1944 rolled around, the Germans had wasted millions of Mannstunden, man-hours, trying to mine-proof the Atlantic Wall against a tunneling threat that was actually much more mobile than they imagined. They expected the Canadians to spend weeks tunneling under their bunkers. They didn't realize that the Canadians had developed the quick push system, a way to do in 4 hours what used to take 4 days. But the most brilliant part of the deception, the Allies didn't just use the pipes to blow things up. They used the threat of the pipes to steer the German defenses. By leaking that certain areas were pre-mined, they effectively funneled the German reinforcements into kill zones where the Allied Navy could pick them off. The pipe mine wasn't just a piece of steel filled with amytal. It was a key that unlocked the German mind and let the Allies inside. It turned the Wehrmacht's engineering strength, their love of meticulous heavy construction, into a liability. The Germans were waiting for a subterranean monster that never arrived, leaving them completely unprepared for the Normandy ghost that was about to rise from the sand. When we talk about D-Day, we usually talk about the Big Red One or the paratroopers dropping into the dark of night. But for the men of the Canadian 6th Field Company, Royal Canadian Engineers, June 6th wasn't just a battle. It was the ultimate field test of a secret they had been carrying for 4 years. This is the Normandy Ghost, a phantom threat that turned the Wehrmacht's own concrete into a tomb. The Wehrmacht had spent years perfecting the anti-tank wall, vast stretches of reinforced concrete 4 feet thick and 10 feet high, designed to bottle up Allied armor on the beaches. The Germans were confident. They knew that a Sherman tank couldn't climb it, and even a direct hit from a naval shell often just chipped the surface. To the German defender sitting in a pillbox, the wall was a guarantee of safety. But the Canadians weren't planning on going over the wall. They were planning on making the wall disappear. While the infantry was clearing the dunes, the engineers were dragging 20-foot sections of pre-filled McNaughton tubes onto the sand. The Germans had braced for sapping, the traditional slow method of tunneling. They expected to hear the clink of shovels for days. Instead, they were met with the hydraulic punch. The Canadians used a mobile version of the jacking system we discussed earlier, powered by the engines of their armored vehicles. In the chaos of the landing, they were driving these 2-inch pipes horizontally under the German seawalls at a rate of several feet per minute.
The German pioneer units were paralyzed by what they saw, or rather what they didn't see. Their manuals told them that a breach of this magnitude required a massive, visible satchel charge placement. They were watching for men running toward the wall with bags of explosives. They didn't realize the threat was already sliding beneath them, hidden by a few inches of sand. When the order to fire was given, the physics of the explosion took the Germans completely by surprise. Because the pipes were buried deep in the subsoil, the force of the blast followed the path of least resistance, which, due to the way the Canadians had tamped the ends of the pipes, was straight up. The seawall didn't just break, it heaved. The pipes acted like a giant underground scissors. A 40-foot section of the wall would suddenly rise 3 feet into the air and shatter into gravel-sized pieces. To a 65-plus man who has ever used a hydraulic log splitter, you know the power of slow, focused pressure. The Canadian pipe mines were the log splitters of the Atlantic Wall. The true ghost element, however, was the delayed fuse. The Canadians didn't blow everything at once. They used a series of timed chemical delay igniters. Imagine the psychological state of the German defenders. One section of their wall vanishes. They rush reinforcements to the gap. 10 minutes later, the ground behind those reinforcements, a road they thought was secure, erupts into a crater 30 feet wide. They began to feel that the very geography of France was betraying them. They were bracing for a high-tech superweapon, when in reality they were being defeated by 1940-era plumbing technology and Canadian grit. There's a common misconception that many of these pipe mines failed on D-Day. While it's true that some pipes were bent by the weight of landing craft, the but is that even the failures served a purpose. A bent pipe that couldn't be fully inserted still created a surface-level blast that cleared the hedgehog obstacles and barbed wire. For the men on the ground, there was no such thing as a bad explosion. Every bang was a step toward the exit of that deadly funnel on the beach. For those of us who appreciate the work behind the work, the D-Day performance of the Canadian engineers is a masterclass. While the world remembers the big picture of the invasion, the success of the breakout from Juno Beach rested on the shoulders of men who knew how to thread a pipe through shifting sand while under MG-42 fire. They weren't just soldiers, they were subterranean architects. They took the defenseless Isle Gamble of General McNaughton and turned it into the hammer of Normandy. The Wehrmacht braced for the wrong explosion because they were looking for a frontal assault on their strength. They never expected an assault on their foundations. By the time the dust settled on June 6th, the fortress Europe had been hollowed out from within, proving that no matter how much concrete you pour, you can't build a wall high enough to stop a man with a better plan and a 2-inch pipe. As we look back at the sands of Normandy and the quiet airfields of southern England, we are left with more than just a military victory. We are left with a reminder that the most profound solutions are often the ones buried just beneath the surface.
For those of us who have lived through the decades following that great conflict, we know that history has a way of staying with us, sometimes in ways that are literal and, quite frankly, dangerous. The problem with a hidden weapon is that eventually the people who hid it aren't around to point it out. Because the McNaughton tubes were designed to be invisible, placed deep underground without disturbing the surface, thousands of them remained in the earth long after the victory parades ended. In the UK specifically, the desperate plan for the defenseless Isle left behind a subterranean legacy that persists to this day. But why does this matter to us now, 80 years later? The reality is that these pipes are still being unearthed. In the last 20 years, construction crews in places like Hampshire and Sussex have stumbled upon strange steel pipes while digging foundations for new homes or shopping centers. These aren't old water lines. They are fully loaded, live Canadian pipe mines, still packed with 80-year-old high explosives that have, in many cases, become more volatile with age. The secret geometry we discussed was almost too effective. Because the Canadians used high-quality steel and the soup was often sealed airtight, the explosives haven't always degraded. They sit there like a dormant heartbeat of the Second World War. When a modern backhoe hits one of these, it's not just a construction delay, it's a national emergency. The legacy of the Canadian engineers is a double-edged sword. On one hand, we celebrate the brilliance that fooled the Wehrmacht. On the other, we must acknowledge the hidden cost of total war. To a mature audience, we understand this trade-off. In 1940, the survival of the free world was worth the risk of leaving a few hidden ghosts in the backyard.
We often talk about the greatest generation in terms of their bravery, but we should also talk about their accountability. In the late 1940s, many of these engineers stayed behind, working with the British Ministry of Works to try and map out the miles of pipes they had installed. But maps get lost, memory fades, and the soil, as we know, likes to shift and hide its secrets. When we think of these men, we shouldn't just see them as figures in a black-and-white newsreel. We should see them as men like us. Men who faced an impossible problem with a toolbox and a bit of architectural judo. They didn't have computers to calculate the boring angles. They had slide rules and levels. They didn't have GPS to mark the locations. They had hand-drawn sketches and local landmarks. There's a certain nostalgia in that kind of craftsmanship. It's a reminder that intelligence isn't always about the most high-tech gear. It's about the most right-tech gear. The Canadian pipe mine was the right tech for a moment when the world was on the brink. The Wehrmacht engineer Fuller teaches us a final authoritative lesson. Strength is brittle, but adaptability is resilient. The Atlantic Wall was strong, but it couldn't adapt to a threat it couldn't see. The Canadian engineers, conversely, took a pipe and a hydraulic jack and moved the world. As we close this chapter of history, we should look at the landscape differently. Whether it's the beaches of France or the rolling hills of England, there is a narrative written in the earth itself. It's a story of how a group of invisible saboteurs from the Great North used the very ground they stood on to upend an empire. But perhaps the greatest reward of this story is the realization that history isn't just something that happened back then. It's something that sits beneath our feet, waiting for us to be curious enough or careful enough to find it. To the men of the 6th Field Company and to the scientific mind of General McNaughton, the walls have fallen, the bunkers are empty, but your geometry of freedom remains. If you've spent your life respecting the kind of quiet, get-it-done craftsmanship we saw from these Canadian engineers, then you know how important it is that these stories aren't buried by time. We're losing the generation that understood this brand of grit, and it's up to us to keep the record straight.
If you found value in this deep dive into the invisible saboteurs, please consider subscribing to the channel. It's the best way to ensure we can keep producing these long-form investigations into the mechanics and the men that history almost forgot. And I'd like to hear from you in the comments. Was there a particular piece of forgotten technology from your time in service or industry that you think deserves its own documentary? Let's keep the conversation going.